Welcome back to the bench. Today we've got a kit build for you. This is an electronic dice kit from eBay. It cost the princely sum of €3.37 delivered and came from iage_electronic. And I'll just post the advert there if you want to have a look and maybe buy one yourself. They come in various color LEDs. I chose to go with the blue LEDs. I thought that would look cooler. So we've got our LEDs. We've got just a single transistor, a single resistor, what appears to be a capacitor, which is actually a tilt switch. So that's going to sense our rolling of the dice, so to speak, or the shaking of it. CR2032 holder, and looking at the thickness, it's designed to take 2. That stands to reason that it's going to need 2 batteries in there with all these LEDs to run. The cutest little buzzer I've ever seen. I mean, how small is this? I mean, it is literally smaller than my thumbnail with a sticky backing on it. So you stick it down. Tiny little switch and our little microcontroller. Not sure who makes this one. Not familiar with the serial number. According to this, it is a 15F104W. So, it could be one of those cheap, kind of PDUC, single program only devices. I'll see if I can find a data sheet and then insert it into the video if I can find it. And then we just got some mounting hardware. We've got some long screws, and what you're supposed to do is, hold the screws to the circuit board with one nut, and then the back plastic also gets one nut, but then again, there's nothing behind it, so it's just going to move. It's got a bit of backing paper still on there. So what I'll probably use instead, I have these plastic standoffs that are actually threaded on the inside. So I use the larger one as a spacer, and then the rear one as a nut at the back, just to hold the perspex in there. So, without further ado, let's get started. I think it's probably going to be easier to do the LEDs first, because the actual battery holder will actually go over the pins of the middle LED there. We do have a flat side on them. Yes, and yeah, so we will trust the markings on the circuit board. It looks like, yeah, there is a ground plane, but there's no what appears to be a common ground. Anyway, we'll trust the silk screen's correct, and we'll put the flat side, which is the shorter leg, matching the orientation on the PCB. So we'll just drop them all in at once. We have a tight squeeze, that one. So we'll just take our piece of foam here, flip that over, and that should hold everything square, but we'll only solder one leg to start off with until we make sure we've got the LEDs seated properly. That way we can just adjust them. Okay, so those look fine. Maybe that one can go down a little bit more. And the rest look fine. So we install the other side of those connections. Okay, they all look fine. Let's just trim the leads. The ones in the middle, on the middle LED, are going to be the most critical because obviously that battery goes on top. So we'll have to see what we do there. Okay, so we're going to have to cut this one as close to the board as possible. Probably about as close as I can get it. Okay. I think we'll probably save the microcontroller till last. Okay, let's do the solitary resistor. Resistance is futile. You will be assimilated. Okay, just a bit of solder down there, get rid of that. I'll go for the transistor next. I don't want to mount this directly onto the board, so I just prop the board up a little bit so we've got a little bit of clearance on our legs. There we go. Straighten that up a bit. These are very tiny connections. Not easy to see when you have old eyes. So we can do both at the same time without bridging them. Maybe not. And we've bridged them. Still bridged. And that's close. Okay. I think our tiny little buzzer should go on next. It's going to be a little bit tricky doing the wires on that. Just take off a little bit of insulation on these. I don't really want to trim the wires in case I make a mess of this. Oh, even our little wire trimmers there are too big for these fine little wires. Even the knife doesn't want to do it. So hopefully the insulation will melt back a little bit while when we try and solder those. So I'll put it here so that the wires come off at a slightly different angle to the solder pads. Now they are marked positive and negative, so we've got a blue and a red wire, so we'll keep to that. Make sure. Let's use a pair of tweezers. Make sure we get that as close as possible. I think probably the best idea is to actually put a bit of solder on both those pads first. And then just reheat them and drop the wires in. One down, one to go. Winner, winner, chicken dinner. Okay, let's get our... we've got a spare LED, I just noticed. We actually have an extra LED in here. Bonus. This is just a tilt switch, so there's not going to have a polarity on it. And yep, that's pretty level. Okay, power switch. We have the power. Readjust that slightly. There. I think I'll bother trimming those leads, they're not that long. Okay, so next is our microcontroller. Make sure we get it the right way around, because that would be a disaster, because it's not socketed. And yeah, I can't be asked to put it in a socket. I don't think I have any 8-pin sockets anyway. And I'm unlikely to want to disassemble this later. Yeah, that's fine. Okay, just the battery holder left, and then we can test that. And yeah, the sort screen indicates which way we need to put that. Yeah, slightly uneven because of that LED there, but not much you can do about that. Okay, so other than the hardware, that should now be complete. So let's pop in a couple of CR2032s. Oh, and what I thought was a buzzer is not a buzzer. It's a little vibration motor. Okay, that's cute. Okay, let's put the hardware on. As I said, I'm not going to use the nuts that came with it. Instead, I'm going to use these. As long as there's clearance, there should be, because the nuts would go on here. Yeah, that looks better. So there we have it. This is a cute little project, and yeah, you've got children. I'm sure they're going to love it. Okay, so you have to turn it upside down to activate it. Two. What's next? 5. 2. 1. 4. 6. I got a 6. I rolled a 6. So yeah, I mean, it actually looks like the LEDs are flickering, so I'm guessing they're pulse width modulated. To my eyes, they're not flickering, but they are actually pulsing. So yeah, if you leave it for a few seconds, they are actually dimming down and going up. So definitely, you know, some PWM going on there. Okay, thank you for watching, and don't forget, if you like this video, hit the subscribe button here, ring the bell icon, and then yeah, you'll get notified of any further videos that I post. And yeah, again, thank you for watching.